Here's another important torque problem here that involves a rod like this. Two forces on it, one 50 newtons up, one 50 newtons straight down, and there is a 30-degree angle right here. And what the problem likes to know, what is the net torque on this bar? So you can think of this bar like a baseball bat or a 2x4 or something, and there's a couple forces on it. The one thing about the bar is it's fixed right here. There's a big hinge right here, which causes the thing to rotate. It doesn't cause it to rotate, but it's sort of a fixed point. It rotates about this point. So there's a hinge right there. So what's the net torque? Well, the working equation we have for torque then is moment arm times force times the sine of the angle between the moment arm and the force. Let's see what we have for these two problems here. So this is sort of the first force right here. This is the second force right here. So what I'll do is sort of write a tau 1 right here, which is the torque due to this first 50 Newton force. So if I just start filling in the working equation, I can see that the 50 Newton force acts exactly at the axis of rotation, so the moment arm is going to be 0. The force is 50 Newtons in there, and it's kind of hard to describe what the angle would be between this force and the moment arm because the moment arm is 0, so it's going to be the sine of something, but it doesn't really matter because this is 0. That means the torque here due to that first force is 0. So even though there's a 50 Newton force acting on this thing, it happens to be acting at the axis of rotation, so it doesn't present a torque on the object. So even though there's a force, it doesn't cause it to rotate, so the torque due to this is actually equal to 0. Go push on a door right by the hinges, even though you're pushing, the door won't rotate, so you're not presenting a torque because you're at the axis of rotation, your moment arm is 0. So what that leaves then is just this last force here. What is the torque due to that force right there? Well, the moment arm is the full 0.1 meters here, which is the length of the board right here. The force is, of course, the 50 newtons right there. That's up here, this 50 newtons. So now the only thing to figure out is what is this angle going to be between this force and the moment arm. So the moment arm is definitely starts at this axis right here, it goes all the way up through the object and stops right here. So what we need to know is what is, like, say, this angle right in here between the bar and the force right there. Something you can probably figure out with a little bit of geometry in here. It looks like it's going to be something like, if this is a right triangle here, something like this. This is 30 degrees, 90 degrees. This is going to be a 60-degree angle up here. You'd have to work a tad bit more over here. I'll just sort of let you figure that out, but I'll just sort of call it angle alpha up there. So it's going to be 0.1 times 50 meters times the sine of whatever angle you figure that to be up there, and it's definitely going to be related to the 30. And so what you get then is that the net torque on this rod here is just going to be that tau 2, whatever you get for that. So you definitely have to find the angle in there, but that will be the net torque. So maybe the semi-tricky part about this problem here is that although there are two forces acting on the rod, one right here and one right here, only one of them actually goes into generating a torque because this one right here is at the axis of rotation, 0 moment arm, 0 torque.